Welcome back everybody. This is a video today that I'm doing is on the 4040, but it might appeal to other people with the desktop CNCs. Now I noticed on the social media platforms and my own channel and what have you that there's quite a number of people out there that don't just have the money to splash out on purchasing the 4040 or any other CNC. I mean, at the end of the day, it is between £500 and £600 wherever you go for it, unless it's a real good discount on. And of course, they always come with that cheap, crappy spindle that's okay just to practice with a little bit of light work, but it's not gonna inevitably it's not going to do what you want it to do. Now, as you've seen in my other videos, I purchased a separate 500 watt, and it's brushed, it's not brushless, 500 watt brushed spindle, and it came as a kit. It came with a power pack, collets, AR11 collets, and it came with one or two other bits and bats. And as you've seen in my previous videos, if you haven't, you know, just look through them, and I'll try and put it at the end of this video. And it shows you the motor control panel that I built, the box, and it installed and it running, and the extra cooling facilities that I did in order to stop the motor from overheating, because one of the downfalls of that particular motor was it overheated, or it got rather hot, because it is only a little plastic fan on top of the motor, and it just sent it out sideways. So I sorted that, and it runs, you can run it for an hour, a couple of hours, and it's absolutely fine. And the other thing that motor came with is a little bit of well, another two things. It came with vibration. Now the vibration's caused because the motor is out of balance, whether the fan at the top or the motor itself is out of balance. So you put a cutter in there that's got a biggish diameter, and that's slightly out of balance, you create that that vibration even more. And I noticed it on mine. And the other problem with the 500 watt is it's supposed to go up to 12,000 RPM. Now I've tachoed mine, and it on the box it runs to 11,500. You're 500 RPM short. It maybe doesn't sound a lot, but it is. But it's not up into the, you know, your 20,000 to 30,000 mark. So you're limited. You're running more or less at the top of the RPM range most of the time. And it's done what but I have been looking at purchasing a either air cooled or water cooled 1.5 kilowatt VFD controlled spindle, same as what I have on my, well, it's water cooled on my Pro machine. So I was looking at using one of those. Now the cheapest I can get is round about between £200 and £300. It's a lot of money to pay out just to put it on this machine, which is basically only a desktop machine. You have a little bit more weight, so everything has to carry that weight. Yes, you can upgrade to the bigger gantry, the stronger gantry that's out there now, but it's costing, and by the time you add it all together, the package, you might as well go out and buy one that will do the job. So I'm not a great believer in just throwing things at it to make it bigger and more robust, because you end up in the realms of paying out for a much more professional machine. So anyway, I looked about and I thought there's got to be something out there that you can get. Well, I found a little gem, and I'll show you in a minute, and I'll show you what I paid for it. And I looked about, and I'd seen these about, and you'll probably all know the name of it. It's called a Rotozip, and predominantly they were used for cutting out sections in plasterboard and other light work. But I thought, well, I'll have a look at this. Anyway, when I looked into it, it is quite a well made, when it came, it's quite well made. it's 550 watts, 240 volts, so it just plugs in. It has 2 speeds on it. Believe it or not, it's 20,000 thereabouts and 30,000. You've just a 2-stage switch, and it gives you low or high RPM. It's a little bit quieter than a router, but a little bit more noisy than my 500 watt spindle, but not much. Well, it came. I was surprised, and I'll show, as I say, I'll show it in a minute. And I was amazed at how well made it was. Now I've actually the way that you have to mount it to the actual CNC is the Z-axis. You have to take the actual collar off that's there for the, whether you've got a 65mm on or whether you've got the 52mm collar on. If you take that off, and then I had to design a collar, clamping collar, that would take the Rotozip. And once I got that installed and tried it, yeah, you won't believe what I paid for it and the condition it came in. And there's lots out there. I'm not saying everybody's to go out and purchase one of these. I'm just saying it's just something that I wanted to do, to see if I could, what's the cheapest I could do to get a spindle on that's better than the 500 watt, but yet it'll give me what I want with it being a desktop spindle. Okay, so what I'll do before I say anything else now, I'll take you over to bench there, and I will show you the actual Rotozip. Right, here we are at bench. This is how it came in a plastic case, and what I paid, the case is worth it. Okay, that's the Rotozip. It's quite a long lead on it, and that's how it came to me. Okay, it has a sort of a depth stop there that's locked on. You adjust that in there, and you can use it as a handheld router, okay, or trimming. That does come off, okay, and it has a deflection there for either sending the you can see it opens up a little slot in there, and when I shut it, it's closed. Okay, that down directs the draft from the motor through into here, and it blows the actual dust away. Okay, now the downfall with this, also I thought when I got it, was the fact that and it's quite a heavy unit, that the actual bush inside there is that it's a 3.175. Take a 3mm, because that's a 3mm bit that's in it. Okay, so you're restricted to that. So I thought, no, you're not, because I've just ordered for about £10 some pence a set of collars for it, which takes it up to 6mm. Okay, which is, it's a quarter of an inch actually, I think it is, and it's they give you about 3 different ones. Okay, so I can put other larger bits in there, which is brilliant. Okay, now as you can see there, that has a collar, plastic collar there. Now that is the only way that you can clamp that into the machine. Okay, now the beauty about this is that handle clips off. Okay, so once I've got the bushes, if I want to take this out and use it as a trim router or a handheld router, I can do. Okay, switch on it, off, speed 1, which is I believe about 20,000 RPM, 3, well up to 2, that is about 30,000 RPM. Okay, now the specs on the motor, I'll read them out to you, is actually 550 watts, between 20 and 30,000 RPM, and it's made in the USA. Is that? It's quite a hefty unit. It's well made. Well, you can see that, and you can feel it when you. There's no play on the bearings whatsoever. Okay. Now, in order to, I'll just move away from that. The cutters that actually do come with it, and you get a little spanner, and I got a core, which is for, you'd plunge through your, there's no like cutting edge on it really at the face. You put it through the plasterboard or whatever, your plywood, what you're doing, and you can do all different shapes. I didn't get it for that. There is an instruction book with it. £10. Shipping was £8, unfortunately, so it cost me £18. Okay, now I would never have dreamt of looking at one of these, but I've tried it and I was amazed. And as I say, I did a search to see how many's out there, and on Marketplace there's quite a number. I've seen them down at £15, £10, £20 with kits and that you get with it. You can even turn it into like a little angle grinder. So anyway, before you show it on the machine, that has to be mounted in the machine. Okay, so hence this is what I came up with. Okay, now as you can see, that takes the centre part there, that takes your Rotozip, and that clamps it in place. Now I've made this, I've got one which is, you'll see the difference, it's a shorter one, and this is a longer one, as opposed to that. This is longer, and the reason why that's longer is because when that's mounted into the base, you can't push the motor through to give you any more depth, okay, or slide it back up. It has to be, it's fixed, so the only depth you can get is with this. All right, now what I did was, because that's clamped, I have on the in one of my kits I have some plastic insert bushes. You put them in with heat, and they're only 4mm, but I didn't want to do that because I don't feel it's strong enough. So what I did was, I don't know what you can see inside there, it's got a metal plate right inside which is to about there. Okay, sits inside that hole and it's to about there, and that takes, and it's a threaded plate, it takes 2 4mm bolts. Right, now this is how it's normally fit on the Z-axis frame once you take your spindle mount out, but I didn't want to just use a bolt at the back. It's got 2 plates that's secured, they're just glued to the back of these. All right, and once you put that in place, then it mounts with the existing bolts that you've got. All right, I think I actually changed mine for just slightly longer ones, and because that's longer, that gives me the ability to actually go down further. So I can, at the moment, the bracket that I've got on is one that I used with trying the rotary axis out. So the one that's on it is slightly shorter, so you've hence to get your depth, so you don't trip out with the micro switches, your limit switches at the bottom. You have to lift and bring your actual workpiece up, so you've got to pack it. But when you put that one in, it takes you down. You can get right down to your wasteboard. All right, now I've obviously tried this because I won't be doing the video otherwise, but what I'm going to do is I'll show you it installed on the short bracket and something that I've already done, and then we'll take it from there. As I say, it's quite a heavy unit. It's not, you know, if I pick that that spindle up that I bought for the 500 watt one, and you can feel it, you can spin it, it just does not feel as smooth as that. Okay, now anybody wants the sort of the STL file for this, I'll gladly pass it on. It's not something it's not top secret, but I'll show you it installed on the machine, and I'll show you exactly what I mean by this. Right, here we are at the machine. As you can see, I'll put these Rotozip there. That's the, what I say is the short one. Now as you can see, that is the longer one. Okay, so hence you don't have to bottom out. Now as you can see, this is with a short one, so it packs up. You have to pack your from the wasteboard up in order to get the depth of cut that you wanted. Okay, I can get down to here, but that one enables you to actually go down further. Okay, with your Rotozip, but just for trial purposes, I'll show you on this one. Now you've got to remember is you're always governed by the height of your gantry and your Z-axis frame. This is on the bottom one at the moment, so that will come up. Right, that sits in there. I have that mine to the side. Remember as well, when you tighten anything up, even though it's plastic, just be careful and make sure you tighten them evenly. Okay, now this is just made out of PLA at the moment, this, and as you can see, it's very solid because it's got the gussets in here, which gives it its strength. But it really wants making out of either, I'm going to print them out of either ABS or I'm going to get the carbon fibre printed. Okay, but it's just to show you this. So as you can see there, that mounts perfectly in there. Control the speed with that, either 20 or 30,000 RPM. That's clamped down. Now as you can see, I've already done a test piece, and what I like to do is to test whether your gantry is running right and what have you, is I do a series of squares, as you can see there, and I step them down each time, and then to a small part in the centre, and then I cut on the line with just the width of the cutter. That steps in, but it also gives you, it shows you whether your machine is running out, because if it's running out, you'll see the lines, they're perfectly square. Okay, I've already checked those, and the distances between them are exactly the same. So and it's just a nice way, I think, of actually testing it. This is actually American white oak, and in actual fact you can see it's a piece that I did the tenons on. Now it goes down to a depth of about 4mm that it's set for in the software program, and the beauty about this is it's easy to control for the speed. It just plugs in and you can knock it off. Alright, you're not worrying about your software controlling and suddenly stopping the spindle, because some of the forums that I read, and some people are having horrendous problems is they set it running on a sample piece, it runs alright, and they set it next running on the actual job and it messes the job piece up. I know a lot are running from the software, but as I say, I use and I've said in all my previous videos, I use the offline controller and the MPG to motion controller to move it about, and it's a great combination. I do the software, I'm not reliant on the PC, something going wrong with the PC and you goose then, because it'll stop dead. I haven't had any issues whatsoever with either offline controller and MPG, and that's how I run mine. I'm not saying everybody should run it the same, but it's just how I run it. Alright, so what we'll do is I've got it set up to run this pattern again, and you'll see how easy this 550 watt motor actually cuts that out. I was amazed. And if you look at the clean cut on that, and that's not a particularly new bit, it's a spiral bit, but it's just one cutting face, one cutting bottom edge. So okay, so that's the next step. We'll get it set up and we'll run the software. Right, here we are at the machine. I've got the program installed, which is just the exact same as that. Okay, the motor's plugged in. I'll set the motor running and I will set the program running, and we'll see how that goes. You notice, I'll stand back from the machine, it's cutting the centre square first, okay, or one of them. But you notice there's no labour in there, in the cutter whatsoever, or the motor. And that's on the 20,000 RPM. And you can always tell a spindle when it's cutting right. There's no change in the RPM and it sounds sweet, and that's exactly what that does. There we go, job done. I shall take that off and I will show you it. Okay, you can see that it's just repeated that, and it's square. It's absolutely perfect clean cut, depth of 4mm, and I was doing it in 3 passes, but it was doing it in 4 passes, plunging in 1mm at a time, and I set that in the software just to, because I'd never tried this before, so I just thought I'd set it easy. I could have set it double that. In fact, it would have taken it all out in one go. So what's it cost me? £10 for the unit, the Rotozip, and £8 postage, £18 and a couple of quid for the 3D printed plastic part that I designed. You know, £20. That spindle is 100% better than the 500 watt spindle I purchased, which is, I think it's a 110 actual spindle, but it has a power pack built into that case over there, so as I've done in previous videos. As you can see, I've just shown you the machine working. It works perfectly. The only downfall would it be if I were using a large surfacing cutter, you know, for your spoil board, because the 25mm or 30mm diameter, it's a little bit at 20,000 rpm. I wouldn't be running that at 20,000 rpm, which I'd probably use the other 500 watt spindle, but I would have to try it to see. But when I've ordered the collets, as I've told you, so I can use most of my cutters, that's £10, so it'll £30 that's cost me. Bit of plastic, bit of time designing that, and the Rotozip itself, and I have seen them on Facebook Marketplace even cheaper. It's just another option if somebody out there has bought the machine and can't afford to pay out for a router. You know, money in, when you consider that this day and age how expensive things are, you know, it's, if you can do it somewhat cheaper, then all's good and well. So yeah, I hope you've all liked this little video, what it's cost, and I shall be keeping this in the machine now, and if I have to adapt anything I will do. There's 2 brackets, one to give me the motor higher up in its Z-axis or lower with this one. Okay, I am doing the other next project, and keep an eye out for the notification on this, and it's something to do with the A-axis, because you remember the A-axis when I did the videos on it, you're limited to what size you can put in it. It's not, I mean, if turning pens fine, or chess piece is fine, but what else is it good for? It doesn't take anything in a large diameter format, because the nature of how it's constructed. However, I found a way that you can get considerably larger items in and longer items, so look out for the notifications on that, and that will be coming up in the future. So right, that's the end of this video. Don't forget, like and subscribe. It means a lot to me, and I'll answer all your questions. It's not a busy time for me at the moment, so I've got time to actually answer them. Well, that's it for the video now. As I say at the end of all the videos, like and subscribe, give me a thumbs up if you like the video. Comments, I'll try and answer them best I can. Anybody's wanting help, I'll try and help them as much as I can. I can't promise I know all the answers, because I don't, but I'll try and find you the answers if I can help. Okay, so until next time, you be safe, you be careful. Bye for now. Bye bye.